Alright, so more parabola examples. This is video 2, part 1. This is actually number 3 in your parabola packet. Um, we're given the standard form, and we want to graph, and we'll find some other information about this. So if you'll notice here, we're given the squared term on the right hand side, and I prefer it on the left hand side. So my first step here is I'm just going to rewrite my standard form to x minus 2 squared is equal to 1/3 times y plus 5. Okay, and again, from the standard form, I can find the vertex. So I've got 2, -5. That's just hk. And I can see that my x is going to be squared over here. X is squared. So that tells me that this is vertical. Okay, if you're ever getting confused, just think back to algebra, and really you only did equations that were y equals x squared something. And x squared always went up and down. That's how you did things in algebra. So whenever you see x is squared, just think back to your algebra days and remember that it's vertical. Okay, and this 1/3 represents our 4p, and since it's positive, p is positive. And since it's vertical, that means it's going to open up. Alright, again, the 1/3 represents our 4p, so 4p is equal to 1/3. So I'm going to multiply through by 1/4 to solve for p, so I get p is equal to 1/12. So this is a kind of a small amount, and we'll do our best to represent that on the graph. It's going to be approximate. So again, what this p tells us is that we're going to go up 1/12 from the vertex to get the focus, and we're going to go down 1/12 from the vertex to get the directrix. So let's start graphing this. So I've got my vertex at 2, -5, so right over here. And since p is positive, it's going to open up. We figured that out. P is 1/12. So I'm just going to go up 1/12. So we're just going to estimate it here to get the focus, and we'll figure out what that coordinate is in a minute. And I'm going to go down 1/12 to get the directrix. Remember, the focus is a point, and the directrix is a line. Alright, so there's our focus, there's our directrix. The focus has to be inside the curve, so we're not going to worry too much about how much it opens, how wide it is, or how skinny it is. Just make sure that when you draw on your graph that the focus is inside. Okay, so I went up from the vertex, so my y coordinate changed by 1/12. So for my focus, I'm going to have 2. The x coordinate didn't change, but I did move up from -5. So I went -5 plus 1/12. Alright, and feel free to just plug that into your calculator to figure out what it is. It's going to be -4 and 11/12, or if you're doing it on the calculator, it's going to tell you -59/12. Okay, I don't really care how your answer is. So there's our focus. Okay, focus. And we also need the directrix. Okay, the directrix is a line. We can see that this line goes through the y-axis, so it has to have an equation of y equals, and it's going through the y-axis 1/12, the distance of p, 1/12 below -5. So it's going to be at -5, and then we're moving down, so minus 1/12. And if we simplify that, we get y equals -5 and 1/12. Again, if you want to write that as an improper fraction, that's fine. So our directrix is, again, a line, and it has equation y equals -5 and 1/12. Okay, the last thing that we need to do is find the axis of symmetry. So I'm going to draw the axis of symmetry in here. It goes right through the focus and the vertex. Okay, so this is also a line, and we can see that it goes through the x-axis right over here. It goes through the x-axis at 2. See if I have a little more room down here. Whoop, that's not what I wanted to do. Okay, so we need axis of symmetry. And again, the axis is a line. It goes through the x-axis, so it's going to have an equation of x equals wherever it goes through the x-axis, so x equals 2. So there is our axis of symmetry. Alright, as usual, as normal, try and get in the habit of writing down your questions so that you can ask me in class. One more example video on parabolas to go.